In this video, we're going to create a walking robot in 20 minutes using the free version of Unity and a few free assets that can be downloaded from the Unity Asset Store. This is the first of a series of videos from the Capital Region Unity Developers Meetup group. The first thing you need to do is download the free assets that you will need. First, download the robot himself. We can use Space Robot Kyle, made available for free from Unity. Next, download the Mechanim Locomotion Starter Kit, which contains a few animations that we will use. Finally, you need an environment for your walking robot. You can choose any city or environment from the Unity Asset Store. The low-poly city block is a good choice. To set up a new Unity project for your walking robot, first create a folder for it. Then, within Unity, create a new project, specifying the folder that you just created. Then import the three assets that you downloaded from the Unity Asset Store. This takes a few minutes to load. We will jump ahead in time and not count that as part of the 20 minutes for creating the robot. To set up your city scene, drag the city block prefab from the project window into the hierarchy. The city block appears in the scene window. Click on some of the buildings and drag them apart to create more room for your robot to walk between them. Position the block in the scene view so that it looks approximately the same as the game view. This will just make it easier to switch back and forth later. Now it's time to import Space Robot Kyle. Click on the Robot Kyle prefab in the project window. In the inspector window, we will rig Kyle, which essentially means giving him a skeleton to define how he can move. Choose Animation Type Humanoid and create the avatar from this model. Click on Configure. This prompts you to save your scene if you haven't done so already, because the rigging process will take over the scene window. Save your scene in the Assets folder inside your project. Under Mappings, choose Auto Map. Under Pose, choose Enforce T-Pose. In the Animation section, uncheck Import Animations, because Kyle does not come with any of his own animations. Double-click on your scene to bring it back. Now drag Space Robot Kyle onto the city block, and Kyle is inside your city. He seems a bit too big though. We didn't intend to animate a giant space robot. This is easily fixed by adjusting Kyle's scale. Let's make him half as big, and then he looks more to scale with the city. Now if we look at Robot Kyle in the hierarchy, we see that he has an animator, but not an animator controller. We need to create an animation controller in the project window. We need to name the new controller. Let's call it Robot Controller. Double-click on the animation controller, and that brings up the Animator window containing an initial animation state machine. We need to drag our new controller to assign it to Robot Kyle's Animator component. Also, make sure we have checked Apply Root Motion and Animate Physics. Next, we're going to use some animation clips that came with the Mechanim Locomotion Starter Kit. These were probably created using motion capture. They are very natural-looking humanoid movements. To start, let's locate this idle clip in the project window, which is simply a natural-looking animation clip of a humanoid character standing in one place. We can preview the clip to get a sense of what it looks like. We'll drag that clip to the Animator window. So now we have an animation state machine with this one clip, meaning that is always what the robot will do. We can run the game and see that Kyle is not doing much of anything, but with a natural-looking idle animation clip. Let's locate the animation clips for turning on the spot. There are some different variations which are different amounts of turning. Version B is turning about 90 degrees, so we will use those. We will drag the turning left and turning right animation clips to the Animator window. By right-clicking on the animation clips, we can make state transitions between the idle state and the turning states. To trigger these state transitions, we need to create a parameter that we will call direction. The parameter will range from -1 to +1. So, for example, we would like to move from idle to turn left if direction is less than -0.5. And similarly for the other 3 state transitions. The remaining detail to tie the pieces together is to give the user a way to change the direction parameter. If we look at the default input settings, we see there is a horizontal axis that is controlled using the left and right arrow keys. So how do we wire the arrow keys to control the direction parameters? We need to create a small script. So we create a C# script in the project window. We name it something like Walking Robot Script. We launch MonoDevelop to edit the script. Here it is typed in. There are just a couple of lines of code. In each video frame, we take the value from the horizontal axis, which the user controls using the arrow buttons, and assign that to our direction parameter that we created in the animation state machine. Save this script and drag it onto Robot Kyle in the hierarchy. Note that we can see that Kyle has the script in the inspector. Let's run the game again, and we see that Kyle not only stands idle, but also turns to the right or left when I press the right or left arrow keys. So now we have a turning robot after only 10 minutes, but we don't quite have the walking robot yet, so let's add walking next. Rather than merely walking straight, we will give Kyle the ability to turn while walking, veering a little, or turning sharply. For this we need to create a blend tree in the Animator window. We'll name the blend tree Walk Forward. Double-click the blend tree to edit it. We will blend together 3 different animation clips, so we will add 3 motion fields. As usual, we will control the motion with a parameter that spans from -1 to +1. Looking back at the animation clips from the Mechanim Locomotion Starter Kit, we identify clips for walking forward, for walking to the left, and for walking to the right. We add those 3 animation clips to the 3 motion slots in the blend tree. Preview the blended animation and try adjusting the direction parameter. You see that blending walking straight with walking to the left or to the right, the result is a blended walking animation with a tunable amount of turn. Let's go back to the top level of the animation state machine. We need to create transitions from idle to walk forward. We will add a new parameter called speed and set up transitions similar to before. Speed greater than 0.5 will trigger the transition from idle to walk forward. And conversely, speed less than 0.5 will make the robot idle again. We also need to add a couple of lines to the script to connect the vertical axis, controlled using the up and down arrow keys, to the speed animation parameter. Run the game again. Now, using 3 directional arrow keys, Robot Kyle can walk forward, turn in place, or turn while walking. You probably noticed that the camera has a fixed location, so watching the robot is like watching a movie. We can make the camera follow the robot so that it feels more like a third-person game. The Mechanim Locomotion Starter Kit includes a camera script called Smooth Follow. Let's drag the script onto the main camera in the hierarchy. We need to make one change to the Smooth Follow script itself. Double-click on the script to edit it. There is part of a line that has been commented out that we do want to edit back in. Now when we click on the main camera, we see the Smooth Follow script in the inspector. We need to set the target so that the camera knows what to follow. We drag Robot Kyle onto the target. Let's run the game again. The camera now follows Robot Kyle, but always from the same angle. Let's change rotation damping from 0 to 1. This allows the camera to swing more freely, and the camera stays behind Kyle. Distance and height can be adjusted to move the camera closer to Kyle. Notice that Kyle can walk right through buildings. We will fix that next. Click on Robot Kyle in the hierarchy. Add a capsule collider to Robot Kyle. Adjust the capsule collider to approximately surround Kyle. Also, add a rigid body to Kyle. Now Kyle is affected by gravity. Let's set the freeze rotation constraints for X and Z. This will constrain Kyle from toppling over, but he can still rotate in Y to change direction. The angular drag of 0.05 is very low, and sometimes will result in Kyle spinning around. Let's increase that to 0.5. Let's play the game one more time. Now Kyle has substance and is affected by physics and cannot walk through the solid buildings. Unfortunately, if Kyle accidentally steps off the ground, he falls forever. That would be a very sad ending to our story, except this is a computer game, so all we need to do is stop playing, and next time, our friend Kyle is right back in the city where he belongs. We hope you have enjoyed this video. Please leave any comments below or on the website for the Capital Region Unity Developers Meetup. If you have ideas for other instructional videos that you would like us to make, let us know that too. Talk to you next time.